Actually, our today's topic is the height of the projectile, as you can see here. But before we get into our discussion, I would like to discuss what does the height of the projectile actually mean. Here we can see the trajectory of the projectile motion, or we can say the path followed by an object being projected. This is the x component or horizontal component of the projectile motion, because you know that the projectile motion is a two-dimensional motion under constant acceleration due to the gravity, means it has two components. So this is the x component or horizontal component, and this is the y component or vertical component. And if we talk about the height, then height is the vertical distance of an object from the ground. For example, at this point, this is the height of the projectile, and at this point, this is the height of the projectile. But in this video, we have to discuss the maximum height of the projectile when its vertical velocity reaches 0, which is also written in its definition. As you can see here, it is written that maximum height covered by the projectile when its vertical velocity reaches 0. Now, let's try to understand this definition with the help of a diagram. So, here is the diagram. Here we can see that this is the highest point of the projectile motion, and when a body being projected reaches its highest point, then its vertical velocity becomes 0 just for a moment. Now let's try to understand its mathematical derivation. In its mathematical derivation, we have the third equation of motion, as we can see here. In this equation, A shows the acceleration, S shows the distance, Vi shows the initial velocity, and Vf shows the final velocity. Here we can see that y is written as subscript with A, S, V, F, V, I. It is because that we have to use this equation for calculation of maximum height, and you know that height is along the vertical component. Okay, so we have written y as subscript with each letter, and bolded letter shows the vector quantity. Okay, now we have to make some changes in this equation in order to derive the formula for calculation of height of the projectile. Here we shall have to replace A by minus g. Here g shows the gravitational acceleration. In this diagram we can see that the object being projected, or you can say projectile motion, is moving in a direction opposite to that of the gravitational acceleration. So we have to replace A by negative gravitational acceleration. The second change that we shall make to this equation is, as we are dealing with height of the projectile, so we shall replace S by H. Here S shows the distance and H shows the height. And third change that we shall make to this equation is, initial velocity component is Viy is equal to Vi sin theta. Actually, in place of the Vfy, we shall write Vi sin theta. Okay, and the final change that we shall make to this equation is, final vertical velocity is Vfy is equal to 0. It is because that when an object being projected comes to its maximum height, then its vertical velocity becomes 0 for just a moment. Now, putting all these changes into this equation, we have minus 2gh is equal to 0 square minus pi sin theta square. In the next step, we shall have minus 2gh is equal to 0 minus vi square sin square theta. Actually, square of the 0 is always 0, because when 0 is multiplied with 0, then we always get 0 as the answer. Finally, we shall have 2gh is equal to vi square sine square theta. It is because that the negative is cancelled with the negative. Finally, we shall have h is equal to vi square sine square theta over 2g. So, it was our discussion of today. I hope you would have benefited from our discussion. If you have any question, then here is my Instagram ID, PhysicsInsight7189. Feel free to ask any question here, and please like my video, share my video, and subscribe to my YouTube channel. And don't forget to hit the bell icon so you can get every new update from my channel instantly. Now I will see you in our next discussion. Till that, take care. Allah Hafiz.